so happy to see you all. Oh, goodness. Can we take a photo? Do you accept my GDPR cookies? Okay, just pretend, okay? Pretend like you're happy. Just one time. Oh, it's gonna be so good. You just watch. This is gonna be the best photo you've taken this minute, for sure. Okay, 1 sec. Everybody, ready, steady, open source. Okay. Open source. Yeah, better. That's better. Appreciate that. It's so hard to get a good photo these days. I have missed you all. You know how awkward it is to take a photo on Zoom when there's nobody there? They don't know what's going on. I'm like, take a photo with me. And like, it's a computer. It's so terrible. I'm so happy to be here with you all. Oh, it's been so long. Do you like the show so far? Best show ever? Did you miss this? I missed this, you know? It's been too long. Okay, anyway, my friends, my name is Josh Long. I work on the Spring team. I'm a Spring developer advocate, a Kotlin Google developer expert, a Java champion, and most importantly, I'm at your service. So if you have questions, when you have questions, please don't hesitate to reach out to me and talk. You can find me on Twitter. How many of you are on Twitter? Oh yeah, good stuff. Rock on. All right, good photos. How many of you are on Twitter? Just curious. Okay, good stuff. Find me there. It's my favorite place to be. Well, for now. We'll see who buys and doesn't buy or whatever. There's that. And then LinkedIn. That's a place you can find me as well. Email. Any of you have email? Email. Anybody? No. Good. Moving on. Blog. I've got a new book called Reactive Spring. It's like the 1.1 edition, whatever. YouTube. I do a Spring Tips video series, and actually, that video, I haven't done one in like a month, and that's because I've been working on a very special Graphql series, introducing all the new stuff in Graphql. So look for that soon, maybe even this weekend if I get a chance to, maybe next week, Wednesday. It's a Graphql series. It's like 8 parts. I think I'll add a 9th, and that'll all come out at once. It'll be everything you need to know to get started with Spring for Graphql. In the meantime, though, you should definitely go see Ross and Stoyanchev and all the other great Graphql talks here that are going to be much better, right? There's that. I have a podcast, a new episode. Who listens to the podcast? I'm just curious. Anybody here listening to the beautiful podcast? It's just me talking to people that are smarter than I am, which I admit is a very low bar. And every week, it's just every Thursday in California, Friday for you here, every Thursday night, and Friday for most people in the world. I talk to people. It's just been really good. People seem to like the show, and maybe it's even during the pandemic when people were not driving. The podcast grew, which is crazy. So thank you for all that. If you're listening, I appreciate you. Okay, good stuff, my friends. So today we're going to talk about building applications intended for production. Today, Kubernetes is production, right, for most people. There's some people that are not using it, but it is, by and large, the place to put your applications. And Spring can really help you here. So we're going to talk about all the different things that you can do to build applications intended for that environment. And if you've seen me talk about building applications intended for production before, that's because I care about production. I love production. You should love production. You should go as early and often as possible. Bring the kids. Bring the family. The weather is amazing. It's the happiest place on earth. It's better than Disneyland. And if you haven't been there to production, if you haven't been to production, well, of course, you can begin your journey here at start.spring.io. So we're going to build a new application today. We're going to build a new application, and we're going to build an application called Customers, just like the first one that we looked at earlier. We're going to use the reactive web support, reactive R2DBC, the Spring Boot actuator, and Spring Native for GraalVM support. Obviously, we'll talk about all these things in time. We're using the just-released Spring Boot 2.7.0, which just came out like last week. Isn't that a coincidence? Funny coincidence. This show happens this week, and Spring Boot happens last week. Anyway, let's go ahead and generate this. And downloads, customers. Okay, so first things first, we're going to build a really simple reactive application. I don't care about the actual application that much right now. We're going to use reactive programming, though, because it gives me 3 big benefits. 3 big benefits that I really care about when I'm building applications intended for production, for scale, for real-life traffic. The first is ease of resource efficiency. That is to say, I can make good use of the resources on my computer. I can reuse threads. When Project Loom comes, and I cannot wait for this, then hopefully it'll be a lot cheaper use new threads, to create new virtual threads. And in this case, it'll be great. In the meantime, threads are still very expensive. And so what you want to do is to write your code in such a way that you are not taking up these threads. And you also want to write your code in such a way that the work of writing threaded code becomes less scary, right? Threading is hard. There's only one person I know that knows how to write safe, effective, scalable, threaded Java code. And it's not me. And it's not you, right? I don't know who it is, but it doesn't matter. Don't write threaded code. It's not going to work out well for you. So let the framework do it for you. Let the runtime do it for you. So reactive programming gives me a way to write threaded code that makes the most effective use of threads, the safest, cleanest code, and also the simplest. That's the first benefit. The second benefit is that because it's all just reactive streams everywhere, you have this really nice single type that you can use to describe data that comes from all sorts of different places. It doesn't matter if the data comes from WebSockets, or Apache Kafka, or REST, or GraphQL, or RSocket, or whatever. It's all just reactive streams. And because you have just one type, this reactive stream, you don't have to spend so much time writing that boring, error-prone code that you see people are writing when they try to connect one system with another. Let's say you want to take data from RabbitMQ and send it out over WebSockets. Well, then you've got to write. Maybe you do something where you create a queue, a queue, and you put things in the message queue. You put things in the in-memory queue from RabbitMQ, and then you pop the messages out in the WebSocket thing, and you send it that way. It gets painful, right? These things don't have the same life cycle, and so you end up having to glue this stuff together. This is the integration code that makes writing distributed systems and microservices so scary. If you take away all that, if you just get to use one kind of thing called a reactive stream, life becomes very simple. And because we have just one type, one kind of thing called a reactive stream, we can compose, like I just said, we can compose these things, and we have a single place in which to add support for robustness, for operators, for retries, timeouts, rate limiting, etc. So it becomes a great way to build services that use threads safely and effectively, that are composed well together, and that remove whole classes of kinds of code that you don't need to worry about anymore, and that are as robust as possible, right? And you have this support from the reactive level on up. You don't have to think about it for each application. So let's build a new service. And again, not too interesting here, just a simple service. I'm just going to use a very simple service here called just a customer service, integer ID, string name. I'm going to have an ID. There you go. There's my basic entity. I'm going to create a repository here. Customer repository extends reactive code repository. Customer integer, voila. Okay. And once I've done that, I'm going to now want a controller, right? So simple controller, add controller, class, customer, REST controller. And I'm going to need to get all that data. So I'll create a REST endpoint like so. Okay. And to do that, I'm going to need a pointer to the repository that we just created. So I'll just inject that here. No big deal, right? Add that into the constructor. Thank goodness I have a faster computer these days. The old one was so slow, right? OK, good. So this is my repository. Now, of course, this is not a MVC repository. It's a REST kind of repository. So I'm going to add that annotation there. Or, of course, I could use @REST controller, couldn't I? Either one's fine. This is the same as this, but I find that nowadays, since we have so many different kinds of controllers, I just use @controller, and if I need to add this, I do. Okay, now, I want to have some data in the database, so of course, just like before, I'll create some schema. So we'll create a new file here called schema.sql, create table, customer, ID, ID, serial, primary key, name, varchar, 255, not null, okay? Good, there's this, and we want some data, of course, just as before. So I'll create some people, I'll insert some people, insert into customer, name, values, and then, some people on the Spring team. I'm sure you know these names, right? Stefan, come on, nope, you can do this, Josh, look at that. An American with accents, I know, it's confusing. Madura, Olga, Yushin, Violetta, and of course, I'm on the Spring team. I don't know why, but I'm lucky. Who else? Oh, Spencer. There you go. There's 8 names, okay? So let's just run this application. We'll run this application. Good. Come on, go faster. The compilation takes so long. Okay, so the application's up and running, localhost, customers, there's our data. It's worked. Of course it worked. It was a demo. It was always going to work. There's no question about this. There's no question. No, that's not why we're here. What I really wanted to talk to you about, as always, is the ASCII artwork. Now, this ASCII artwork is very important to me. Anybody who knows me knows that I've spent almost a decade talking about this ASCII artwork. And I'm here to bring some bad news, my friends. Right now, there's a feature in Spring Boot, a wonderful feature that makes children's hearts grow bigger and happier, where you can take an animated GIF or a JPEG, and it will automatically turn that animated GIF or JPEG or PNG into ASCII art. Did you know about this feature? It's magical. It's wonderful. And it's disappearing. They're taking it away in Spring Boot 3. Don't cry. Be strong. Oh. Anyway, the reason they're doing this is because it brings all of aught. To make that work, we have to import aught. And so I think, as I understand it, to make it easier when you're building native images with GraalVM, they got rid of that. Okay, fine. You can still just take your image, go to some website, turn it into ASCII art there, and then put banner.txt in the folder, and then that'll work. But it does make me sad to think that that wonderful feature is going away. Okay, so we have our application. It's good. I want to take this to production, right? It's a simple REST endpoint. So I'm going to use the actuator, right? The actuator are a set of managed HTTP endpoints that give you information about the application. So I'm going to say expose all the endpoints. I'm going to say health, show details always. And I'm going to say I want to use the Kubernetes probes to be true. I'm going to enable that to be true. So let's go ahead and restart. Here we go. Okay. Localhost actuator. And voila. Okay, and we've got these managed HTTP endpoints, and there's a lot of stuff here. I think you have seen these before. The beans endpoint shows you all the different objects and how they are related to each other. Caches shows you all the cache managers. Info, we'll talk about. Health, we'll talk about. Config props shows you all the different properties that Spring Boot will respond to on the class path. Environment shows you the environment variables. Loggers shows you all your loggers. Heap dump and thread dump you can use to debug your heaps and your threads, respectively. Metrics is powered by Micrometer, which is an abstraction for, it's a vendor-neutral application metrics facade, and it talks to a number of different time series databases for capturing statistics, including, but not limited to, VMware Wavefront and Google Cloud Stack Driver, and of course, Prometheus, which is very common in the Kubernetes ecosystem. We have mappings, which shows you all the different HTTP endpoints that are exposed for traffic, for production. Can you see that? Yeah, you can. It's not great, but you can. So, okay, we've got this stuff. Good stuff, right? Is it easier to see it that way? No, it's not. Whatever. So we've got this stuff. Now, what I want to do is customize a few of these things. So we talked about info. Info is an empty page, tabula rasa. You can do whatever you want with this. You can put information in there. And the way you do that is you say env info enabled equals true, and then you can say info dot message equals hello spring IO, right? Is that, yeah, there you go. Like this. Oh, and of course, we'll, whoop, nope, that's not going to work. Let me see. Oh, if it's on the, anybody remember the code for, let's see. Oh, no. Upside down exclamation point. It's so important that we not be wrong. Good. Is that it? Okay. There. Okay, so there's my message, yeah? Restart. Here we go. Info. Nothing. What? Info enabled equals info. Oh. Info.message equals this. Restart. Okay, there it is. There's our message. No! Are you kidding? Whatever. Try and do something right. Anyway, there's our message. So this is configuration. It's great. You can put information there. A lot of times you want to deploy the application into production, and when you deploy the application, you want to see what commit triggered the change that resulted in the code that is in production. So you can use the Git Commit Id plugin. It's a Maven plugin that we pre-configure for you in Spring Boot. So Git Commit Id, you go down here, okay? There it is, right there. Copy this plugin, copy and paste to pom.xml, down here, build plugin, voila. Okay, there's our custom configuration, right? We're just adding this plugin to the build that was already there. So plugin, get rid of that, good. Plugins, good. Okay, there it is. I'm adding this plugin to the build, and that's it. So it'll automatically capture information about the Git repository. So git add, git status, git commit, git add.maven, git add.git ignore, git commit YOLO, okay? Now, Maven, skip tests, clean package, okay? Uh-oh, downloading new versions of the plugin. Here we go. What could go wrong? Nobody used the internet. Sharing is caring. Oh, what happened? Input.length. What does that mean? Okay, well, in theory, is it my property file, I wonder? In theory, that created a file here, target, git.properties. There it is. So you can see all this information has been captured in the output for the build. So now, I can restart this. I hope. It captured information about the git commit and all that. So now I go here. Oh, we broke it. So sad. Wait, is it this? Like, what have I done to deserve this? Let's just get rid of that. I think it's causing me trouble. I have no idea. Build. I'm not sure if that's going to delete everything. We'll just try. Wait, maybe I should just... Okay, it's worse than before. Somehow we've broken it worse than before. Okay, well, whatever. Assuming everything was going well, let's just see. Get that. And then terminal, Maven skip tests, okay, clean package. Please don't break. This is so very important. Okay, seems to, I can't believe it, but I really think it was that exclamation mark. That's so embarrassing. It's really embarrassing. Okay, look. So there's the message, there's the git commit information. Great, so now we know what version of the code is running in production. I also want my application to give us a useful health endpoint. So the health endpoint gives us, your database, your file system, etc. But Kubernetes has two specific concepts. One is called a liveness probe, and the other one is called a readiness probe. The readiness probe tells you whether the service is ready to be put into production. The liveness probe tells you whether the service is still alive and should stay in production. The readiness probe is used by Kubernetes to determine if the application should start up. The liveness one is more or less exactly the same as the regular health endpoint by itself. So liveness, / liveness up or readiness. Yeah. Now these probes are there for you out of the box, and you can manipulate them. You can contribute to them if you want to. So I can say @controller class health controller, private final application context, and we say, this is not very restful, don't tell anybody, void down, and I'm just going to publish an application context event. I'll say that I want this to be a liveness event that says that the application is broken, okay? So when somebody calls this endpoint, we're going to publish an event from one Spring Bean in the application context to the others in the application context, all right? So we'll just restart this. Liveness is here, right? It's good. So now I go here to 8080/down, and whoops. You know why? It's because we have this target directory cached from the previous build. Let's restart. Okay. So here, liveness is up. Refresh that. Now it's down. Okay. So we're just using that to signal that this is down. If you curl this endpoint term, curl, right? It's down, and you get -v 503 service unavailable. So your container orchestrator, Kubernetes, is going to look at that and it's going to go, okay, that pod is sick. it needs to be destroyed and then another one created. So you have a question then. What should happen? Normally, when your pod gets taken out of rotation and from the load balancer, they send sig term and then sig kill, these signals, sig term, sig kill. It happens almost immediately. But what if you have stuff in the middle of a transaction? What if you have stuff up in the air and you want to finish that work first? Well, you can take advantage of something called Graceful Shutdown. So you go here to your application.properties, Graceful, sorry, it's called SHU. I'm super careful when I type that property. Okay, so by default it's immediate. I want graceful. And then you can configure how long you want to wait. So if you wait, you say 30 seconds, it's going to stop accepting new requests, and it'll finish everything that's in flight. Then, after 30 seconds, if the application context hasn't already finished, then it will shut everything down, right? It'll actually let you clean up your application state and finish any existing work. It'll stop accepting new requests as well. You have to, of course, change your Kubernetes, your YAML for the pod and for the deployment to reflect this timeout, right? This grace period. But the point is that it makes it very easy to gracefully clean up your application. So now I've got an application. We're getting closer to a point where we can take it to production. I want this to be configured. I've got configuration in this property file. Well, did you know that we have a special syntax here now since Spring Boot 2.4 where you can do --# and you can have configuration sets that are only activated in certain contexts. So here I can say activate on cloud platform equals Kubernetes. So here I might also want to import configuration. You know that you can import configuration from other files like class/path file, etc. But there's also something called a config tree. And this config tree syntax is meant to work with the directory structure that gets created if you take a config map in Kubernetes, which is like a dictionary of keys and values. It's meant to take that directory full of configuration. When you take a config map in Kubernetes and you mount it as a volume on your pod, it creates a directory where the files are named after the keys in the config map, and the contents of the files are the values of the keys in the config map, okay? So it's a very strange structure until you kind of do it a few times and see it, but you go here, cd desktop, make dir config, cd config, touch, echo, 8181, server.port, so cat server.port, pwd. I'm going to say desktop config. Don't forget this trailing /. Super important. You need this, okay? So let's go ahead. It's not running in Kubernetes right now. So by default, server.port is equal to 8080, isn't it? Well, here we've got it port 8181. I want this to pretend that it's on Kubernetes. So I'll say activate on Kubernetes, or sorry, I'll say cloud main platform equals Kubernetes. And that's a property that for my local environment, for testing locally, I can just pass in as a program argument, right? So go here, modify options. Be very careful never to select this one. That's a dumb property. Never, be careful. It's very easy. Maybe you're drunk, maybe you do something stupid. You're scrolling down like, oh, hide banner. Then what happens? Nothing good. Nothing good. So I'm going to go down here. Let's see, override configuration properties. Somehow they made this more confusing a few years ago. I don't understand. Oh, let's see here. Maybe? What does that even mean? Okay, whatever. Program arguments. Did you see that in there somewhere? Oh, here we go. -- equals Kubernetes. Okay, so I'm just saying -- spring main cloud platform equals Kubernetes. Hit apply, hit OK, restart. Okay. Okay, so now it started on port 8181, right? So it thinks it's running in Kubernetes. And by the way, you can do this for Java objects as well. Did you know that? You can actually, so this, let's say I have a component, class, application, Kate, runner, whoops. Okay, event listener, application ready event, void run, public void run. So, hello, Kubernetes, right? I want this to only run when we're on Kubernetes. So I'll say cloud platform is equal to Kubernetes. Good. Okay, whoops. So there it is right there. It says hello, Kubernetes. Now we go back here, change this so that it doesn't think it's running in Kubernetes, hit apply, hit OK, restart, and we should see it start again on port 8080, and it won't have this hello Kubernetes, right? Okay, there you go. So now you've got dynamic Kubernetes-aware specific configuration. The next thing, I'm going to just delete that because I don't want to accidentally still have it running in any case, in case I have an environment variable or something like that. Okay, so now we've got configuration. Now it's time to talk about how to get this into production. Obviously, you can't get into production without some sort of, binary that you can take. Now, here, we're going to use something pretty interesting. We're going to use the support for building native images with GraalVM that exists today, thanks to a project called Spring Native. Now, you saw earlier in the keynote that we looked at some of the new support for native images with GraalVM in Spring Framework 6, but that's coming out later this year. In the meantime, if you're using Spring Framework 5, we have a good option for you called Spring Native. Spring Native is a build time tool chain. It looks at your code, and it understands all the places that you're going to do things that will be of interest to GraalVM. GraalVM is a very interesting piece of technology. The way it works is it takes your code, and it looks at something called reachability. It looks at all the methods that you call, and all the methods that that method calls, and all the methods that those methods call, and all the other methods, and so on. And it says every class that's involved in this chain is said to be reachable, okay? It keeps those types in the native image heap, in the native memory of the resulting binary. But everything else it throws away, okay? And this is not great because Java is a very, very dynamic language. Even though sometimes it feels like C and C++ and whatever, it's actually much more like JavaScript and Ruby and Python and Perl and so on. It's got a very Lisp, small talk. It's got a dynamic runtime. You can compile a Java class at runtime, load the class into the class loader, create an instance of that new class that you defined in a string at runtime, reflectively call methods on that class, create a proxy of that class, serialize an instance of that class, all after the application has started, right? And the reachability algorithm doesn't see any of this. It hates when you have fun. So you have to tell it about all this stuff. So Spring Native provides most of that configuration for like 99% of the case. But if you do any of these things in a way that Spring doesn't know about, then you need to provide configuration. So we have this framework built on top of Spring Native. It's a compile time. It's like auto configuration for these hints. We call them hints, okay? Now, you can use these hints. There's a lot of hints out of the box. And most of the time, you won't even need to know. But they are there. They're actually acting on our code. So let's go ahead and turn this application into a native image. So I'm going to do Maven skip tests. And the reason I'm skipping tests here is more a function of time, not quality of code, although I haven't written any tests. But even if I had, what this is going to do is it's going to compile the application tests into native code, and then it's going to execute that native test. Then, if that's okay, it's going to compile the actual application into native code. So GraalVM takes a long time, because remember, it has to do this reachability algorithm for everything on the class path every single time you recompile. It's not just compiling the .java source code in your directory. It's doing this analysis on everything. And it throws everything from the JDK and from the class path that you're not using away. This makes the application that results from it very fast, very, very lightweight, but it does take time. It's like WebSphere or something, old school. It takes a minute, you can make some coffee or something, have a tea or a sangria, something. So here we go. Wait for it. By the way, you can't see this, but my fan is making no sounds at all. And it's because I shut down Slack. And no, I'm kidding. I kid. But it's because I'm using a Apple M1, which is, it has its pros and its cons. One of the pros is that, you don't become, if you do this on an Intel and you put it on your lap, boom, you're sterile, right? Instant sterility. But in this, it's pretty good. Okay, so customers, so you can see it took a minute and a half, long time, really long time. So you would do this normally in your, wait for it, security. It's going to ask for network security or something. Why didn't it do that? There you go. Well, okay. Anyway, there's the application. It's up and running. It took 74 milliseconds. Okay, pgrep customers. There's this. That's the PID, yeah. And I have a little script here. Josh env bin RSS by PID, and I can just show you the script. All this does is it runs this command, ps-o RSS PID number, gets the last number, and then prints out everything so that we can kind of see it. So let's run that here to PID. Okay? So it's taking 107 megs of RAM. I'm on a Mac. Okay? The binary will actually take less on Linux, I found. So just keep that in mind. There's differences there. The fact that we're on a Mac doesn't really change anything, though, because what you're going to do when you compile for production is, of course, you're going to compile probably for Linux. You're going to have it in a CI environment. There is a GraalVM GitHub action that you can use, and GitHub actions support matrix compilation. So you can build one, you can do the whole suite of tests for your Mac, Linux, Windows, whatever, and it'll produce a native binary at the end of that. The result is that you can then deploy the right Linux binary to your application. Or if you want to compile a Linux binary on Linux on your Mac, you can do that using build packs. Okay, and I don't have enough time to show you all that, but build packs are a way of taking your application code and turning it into a Docker image. So you saw us talk about this earlier. This is a Cloud Native Computing Foundation specification, and it's really, really convenient because you have one recipe for building Docker images out of your Spring Boot application. There should not need to be 500 different ways to write the Docker file, right? We can do better. We owe each other more than writing Docker files by hand in 2022. So use build packs, and then if you're using native, right, you see that the Spring Boot build here is already configured. Let me Control-C that. It's already configured for native, BP native image. So the build pack support in Spring Boot already knows about the native image. So it'll build a native image inside of a Docker image. Then you can Docker tag and Docker push that to your container registry of choice and go on to production. Okay, so now we have, my friends, let me run the application again. Customers, localhost, customers, there we go. Life is good, okay? So now we have our data. We have a service. Let's build a client, okay? So this client, I'm going to build an edge service, okay? And this is pretty trivial. We're going to bring in Spring Cloud Gateway, the reactive web support. We're going to use, what else do we want to use here? GraphQL, right? We use Spring for GraphQL. That's the new stuff. That's really cool. And good, we're just going to use this to build an edge service, to talk to our downstream service. Now, go to the downloads directory, uao edge.zip. Oh, God, we have a lot of time. Good. Edge application, wait for it to download. Wait for it. Everybody get off the internet, please. Oh, looks like it's coming along. I just said we have 16 minutes, and just as soon as I said that, Maven. Come on, Maven. I didn't mean for you. There you go. It seems happy again. Okay, so there's my application. What we want to do is we want to build an application that allows us to talk to the downstream service. Remember, we have that microservice, but we're going to have lots of different clients all over, right? Lots of different clients, iPhone devices, Android devices, TVs, your cars have SDKs now. There's still that one person using Windows Mobile. There's lots of people using lots of different clients, and we need to accommodate those clients when they talk to our service. So those clients are going to have their own bandwidth constraints, their own power constraints, and so on. They will talk to the edge service, and there you can sort of homogenize all the requests and then send them to the downstream microservices, which I assume are mostly written with the same stack, the same style, the same protocols, etc. That's one thing you want to do. The other thing you want to do is you want an edge service to give the client a view of the data that matches what they want. Remember, we talked about this earlier in the keynote, but it's very common. You have different microservices. They store their data in different places. But from a client perspective, I want all the data in one network request, and I don't want to spend so much time loading all this extra data from different microservices and doing the service orchestration and composition on the client side. That means that my iPhone developers and Android developers all need to write this scatter-gather orchestration code. That's not something you want to do. As you start to build more and more services in production, this will start to become more of an issue. So it's better to handle that for them at the edge, okay? So one way to easily handle that is just use a proxy, right? Spring Cloud Gateway. So we're going to use Spring Cloud Gateway, route locator builder, RLB, okay, .routes.build, route rs, path. So what I'm doing is I'm saying when a request comes in to this server on port 9999, then 8080/customers, right? When it comes into proxy, 9999/proxy, send the request to this host and port, localhost 8080. The problem is, the request comes in with this path right here, /proxy, and I want to change that to be, customers, don't I? So I use a filter. These filters are where so much of the power lives, right? You need to, you don't need to use all of them, but you can do a lot of very interesting things here. You can say add these headers, access control out origin, great, etc. Okay? So let's just try that here. We're just adding cores support, right? We're just adding some basic things, but you can do retries. You can say I want to specify retries. I want to do request rate limiting, right? I can do all that kind of things as well. I can add headers. I can change headers. I can do your path rewriting, etc. Now you can do this with a Java API, just like I'm doing here. It's very easy. But Tanzu, the division of VMware where I work, we have an amazing, not open source, it costs money, Kubernetes version of Spring Cloud Gateway. It's like an ingress controller for your Kubernetes cluster. And you can use that to declaratively define these same rules and same filters, but at a cluster level instead of having to deploy it for each microservice. So localhost 9999/proxy. Okay, so you can see I'm getting the same data back, but I also get this extra new header. And I'm not talking to 8080 customers, I'm talking to 999 proxy. Okay, great. So that's one thing I can do. And remember, I'm using an M1. Netty has this scary, stack trace that it prints out because it can't use JNI to load this native thing. But it works just fine, as you can see. So don't worry about that. Hopefully one day they'll fix it. I guess nobody has an M1 anymore. I don't know. It's just very strange that kind of bug should be there for like 500 years. The next thing we want to do, we looked at Spring Cloud Gateway. Spring Cloud Gateway is a great way to proxy data back and forth. Another thing you could do is just use, the reactive web client, that kind of thing. We talked about that earlier. What I want to do instead, though, is instead of showing you reactive code to make a network call, since we've already seen that before, let's talk about GraphQL a little bit more here, okay? GraphQL, you're going to hear a lot about this, and I really like GraphQL. GraphQL is, I'm ashamed that I only learned about it recently. A few years ago, and during the pandemic, I only started to learn about this technology. It is something that, if I had known it existed, I would be a lot more invested in. I would have been a lot more invested in. Thank goodness the Spring team built this integration with the GraphQL Java team. The GraphQL Java team built the most scalable, most robust version of GraphQL for Java out there. You may have seen late last year, I think, where Twitter, the company, came out and said, hey, oh yeah, we're replacing the GraphQL Java engine the GraphQL engine that we use for our web services, we're replacing it with the GraphQL Java project. And they talked about how just doing this, they replaced their Scala one with this new one. It gave them much better performance, and it was much more efficient as well, right? It's really good stuff. It powers large websites, right? So you can use GraphQL Java, and you can use GraphQL. If you want to see, I think this one's a pretty interesting API. How many of you know SpaceX? Right? They're a space company, something. It's not Star Trek. We're not there, but it's interesting, They have this API, right? API.spacex.land, and you can kind of see what the benefit is. Let's say I want to see all the capsules. Well, here it's saying, look, you have to specify what fields of the capsule you want. Great, I want the ID, okay? Well, I also want the landings. Well, landings, great, okay, show me that. There's one. I also want the missions, but the missions is it's another object with subfields, so I have to say I want the flight information, and I want the name. But I only get the data that I want back, and it doesn't matter where this data comes from. This might be a separate microservice from the data that gives me the landings and the IDs. I don't pay that cost unless I ask for it, okay? You can see that we have this very nice introspectable endpoint. We have the ability here to query the different types of data, different kinds of queries that we have. We have the ability to ask, hey, GraphQL, what questions can I ask you? Hey, GraphQL, what commands can I give you to change things? And then also, is there any sort of long-lived feeds? These are called subscriptions. A subscription in GraphQL is a thing that gives you data over time. Imagine stock ticker feeds and sensor data and this kind of stuff, right? Stuff that keeps going. It doesn't just end when you make the request. You would use a subscription for that. These are the three main things. And I love this about GraphQL because that's it. You're done. You now know 100% of all the possible operations that you can do in a GraphQL application. Feels good, doesn't it? When was the last time you were able to learn something like, imagine learning the basics of a whole protocol in less time than it takes to go to the toilet. You know what I'm saying? That's nice. Can you do that with HTTP? No, of course not, right? Like, I can't even figure out what the correct way to make a change with HTTP is. You know, it took me years. I'm still figuring it out. Like, if you want to make a post versus a put, do you do option? Do you do a location header? Is it 200 or 201 or 202? I mean, I know this stuff, but I've been trying for 20 years, right? This stuff is not fun. It's not easy to think about. GraphQL just solves all that. You don't have to worry about it. I'm using HTTP here, but GraphQL doesn't care about the fact that you're using HTTP. It's just an accident. It's a transport. So if you're thinking, well, this is not very RESTful, you're right. It's not. That's by design. It's a feature, not a bug in this case, right? REST is awesome. But in this case, I want something that just solves my problem of letting me read, update, and work with data. So I'm going to build a GraphQL endpoint here called a new folder. Call this GraphQL. And I'll create a new file in here called schema.graphqls. And again, you have those three core types, query. I'm going to have a collection of customers, like earlier. I'll have another type called customer. Okay. ID is an ID, well-known type. We'll have a field called name. And I have to implement that here. So I'll say add controller, class, CRM, GraphQL controller. And I'm going to create a method that returns all the customers, right? So again, we're going to create a DTO for that type, string name, customers. And I'm going to map this. This method will provide the resolver for this field called customers. It's going to return 0 or more, 1, 2, 3, 5, 10, a billion, whatever, customers, okay? So I can return that like this. Return, and I'll just use, again, I'll use the private final web client HTTP, add the constructor arguments, return this.http.get URI localhost 8080/customers.retrieve body to flux customer.class, okay? So I'm just returning this reactive stream of data from the network call. Now, of course, this is just one network service, but what if I wanted to have more data? What if I have a type called a profile, okay? So the profile is, whatever, it's got an ID and some other thing, okay? We don't care about it, where it comes from, but imagine it's a separate microservice. But because we've described that the customer also has a profile, so profile, okay? So now I'm saying for every customer, there is a profile. Well, I can get that, I can create a resolver for that as well, but here I need to use the lower level schema mapping. So the type here is called customer, and I'm going to return a profile. Now, again, you can just imagine that I've got some other microservice where I make this network call. It doesn't really all that much matter, does it? Profile. And of course, in order to resolve that, I need the root customer. So I inject that here as well. New profile, and I say customer.id or something, right? Any number, it doesn't matter where you get this. This could be a database, it could be a network call, but the point is, I have a handler to return the customer, returning profile for customer.id, yeah? Let's restart this. Okay, here we go. Whoops, oh, I need the web client, sure. So, bean web client, return. Good, restart. Here we go. No time to drink. Localhost 9999. Oh, and I want to also query all this, so I'll say Graphql enabled is equal to true. Restart. Okay, localhost 99, Graphql, goody, okay? So there's the endpoint. There's the Graphql client. I can say, I want to send a query. Here we go. Customer data. I want that. I want the ID. Great. I want the name. Great. I want the profile, right? So right now I'm just getting the ID and the name, but also now we know that there's this other endpoint that gives me profile information. So I can say, okay, fine, show me all the profiles. And of course, if I do that, I get the IDs back as well. Now I'm getting this data as I need it, but I don't pay for the cost of getting it if I don't need it. And the nice thing about this is, if like in this case, I'm doing n+1, right? n+1 is not very good. What did I type here? Returning the right thing, okay? n+1 is not very good. I can also use batch mapping, right? So here, I say for each customer, I'll return a profile, customer, and I get a list of customer, right? So now instead, maybe I have a network, maybe I have a service over the network where I can say, for all of these customer IDs, give me all the profiles. So now it's not n+1. Instead, var map equals new hash map, you know, and it'll be a hash map of customer to profile for var c customer list map.put c new profile c.id return map. Okay, so now I'm doing the same thing, but behind the scenes, the engine is going to call that method instead, and it's just very smart. I can now make a network call, and instead of making one call for all the customers and then 8 calls for all the profiles, now I just make 2 calls, one for all the customers and another one for all the profiles. So I get this really amazing ability to stream, oops, profile. Oh, come on, Josh, you got this. I get this really amazing ability to compose, to combine these different services seamlessly, and the client doesn't care how that happens, and we get the most efficient version of the code. Yes, I'm making network calls, but I have options to take advantage of, you know, services and so on, where I can avoid round trips. It's not inefficient at all. It's as clean and elegant as possible. The other thing that's really interesting about this is that if I have 10 customers and each one has a profile, if I use reactive types down here, if I used a mono of profile, then that network call is asynchronous. So it would call all 8, it would call the same network service 8 times, but at the same time. So I'm not serializing the requests. You get the benefits from using reactive programming without having to write any really complicated scatter, gather, service orchestration, and composition. I think this makes this an ideal way to describe your API in a way that your clients can use. All right, my friends, well, we've just looked at a few things that I hope will help you find your way to production in terms of Kubernetes. Obviously, I think about production, I think about building services. I think you really need to think about how your services scale, how you package them, what they look like in production. The interesting business logic, that was like the first 5 minutes of this talk. Everything we looked at after has very little to do with business logic and more about how to make these applications behave correctly and scalably and reliably in a production environment. Who got something out of this? Who learned something new? Oh, that makes me so happy. That's good. I really appreciate you. I'm so happy to see you all. It's been so long. I hope you have a great show. I'm doing a talk on writing operators with my friend Cora Berkeley. She's the legend that you saw earlier today with me on stage in the keynote. She's the one who managed to, you know, turn an application and get it into production in like less than 10 minutes. Crazy. Yeah, we'll be doing a talk tomorrow. Come join us for that. Thank you so much. Also, remember, you know, wear a mask. Some things shouldn't be open sourced. I've always said that. Don't open source the virus. You know, be good to each other, my friends. Thank you.